locating irrational numbers on the number line. Locate under root 3 on number line. Let me go back to what we did in the previous videos, where we tried to locate under root 2. Suppose I have this figure A, B, C, D. We had computed that this line was under root 2 when all these were 1 each, because this was the hypotenuse. Now I need to locate under root 3. Okay, and I know that one of the sides in this particular triangle was under root 2. Now under root 3 can also be written as under root 2. Sorry, it's getting a bit confusing here. Under root 3 can also be written as under root 2 whole square plus 1 whole square. You must be thinking, why am I using these numbers and not something else? The fact is that in this example, we had one side as under root 2. And again, I need to use the Pythagoras theorem, which says that the hypotenuse square is equal to side 1 square plus side 2 square. If I go by this, I already have one side which is under root 2. So what do I need? I need another side in a right angle triangle where it is 1. So what I do is I just rub this thing off because this is not required. Now I create a line which is perpendicular to C and take it to another point, let's say E, such that the length of EC is equal to 1. Draw a perpendicular to point C with length of 1. And then I kind of connect AE. So applying this formula, what do I get? I get AE square. Now AE square becomes the hypotenuse because this is the right angle triangle and this side is opposite to the right angle triangle, is equal to, or maybe let me not do this like this, EC square plus AC square, or AE is equal to the under root of EC square. Now EC is under root 2 plus 1 square. So this will give me under root 2 plus 1 is equal to under root 3. So I now know that the length of AE, which is this particular line, is equal to under root 3. Now what do I do to find out this length on the number line? Exactly the same thing. I create a number line 0, 1, 2, 3, -1 and so on. I again put this point A here on the number line at 0. Let me use a different color. AD is equal to 1. So I put in D here. I extend this. This is point C. Then there's a perpendicular here. This is point E. And this is AE, which is equal to under root 3. I just put in all these numbers out here. Just like I did in my previous example, here also what I do is I put in the needle of the compass at this point, I measure the distance of AE, and I draw an arc over here. this arc is going to cut somewhere around this point, and this point, and the distance which is there here, is the distance which is equal to under root 3. Now, you must be wondering why I'm using this particular point. I mean, I'm not doing the exact calculations, but as you do it, it will come here. We know that under root of 4 is equal to 2, which is this point, and under root of 3 is less than 2. So therefore, it has to come between 1 and 2, which is somewhere around this number. So that's how basically you locate the irrational numbers on the number line.